This is Voyager Notes, a transmission from 25 billion kilometers, still transmitting. On the 14th of September 2015 at 9 hours 50 minutes and 45 seconds UTC, a pattern swept across Louisiana and then Washington state in the span of 7 milliseconds. LIGO's Livingston detector registered it first. Hanford followed. Both instruments recorded the same characteristic sweep, a frequency rising over roughly 1/5 of a second from about 35 Hz to 150 Hz, then silence. The pattern had a name before anyone opened the data file. It was called a chirp. The event is designated GW150914. It is the first gravitational wave ever directly detected. The signal was produced by two black holes, one carrying about 36 solar masses, the other about 29, completing their final in-spiral and merging 1.3 billion light-years from Earth. The LIGO Scientific Collaboration and Virgo Collaboration published the result in Physical Review Letters in 2016, and Abbott et al. 2016 remains one of the most cited observational papers in modern physics. The detection confirmed a prediction that had stood untested for 100 years. It also opened a set of questions that the confirmation itself cannot close. Loop #1. What exactly happened at the moment the two black holes became one? That question will carry through everything that follows. LIGO, the Laser Interferometer Gravitational Wave Observatory, works by measuring distance. Each detector is an L-shaped tunnel, 4 kilometers per arm. A laser beam is split, sent down each arm, reflected back and recombined. When a gravitational wave passes, it stretches space-time along one axis while compressing it along the other. The arms change length by a fraction so small that thermal vibration, seismic noise, and quantum fluctuations in the laser photons themselves all threaten to drown the signal. The engineering required to isolate a displacement smaller than 1/1000th of a proton's diameter from every other source of motion on the planet represents decades of incremental, unsexy refinement. The detectors had been upgraded to their advanced LIGO configuration and had been running for approximately 4 days in engineering mode when GW150914 arrived. It was not supposed to be a science run yet. The signal came anyway. The waveform matched general relativity's predictions for a binary black hole merger with a precision that left very little room for interpretation. The in-spiral phase, the long, slow approach, produced the lower frequencies. As the two objects drew closer and their orbital velocity increased, the frequency climbed. The merger itself produced the peak amplitude. What followed was a ring down, the newly formed single black hole oscillating toward a stable configuration, radiating the last of its asymmetry as gravitational waves. The entire detectable event lasted less than 2/10 of a second. The energy radiated in that interval in the form of gravitational waves alone exceeded the combined luminosity of every star in the observable field during that same fraction of a second. That number came from the waveform. It is not a speculation. Loop #2. The ring down matched the predictions for a black hole settling into a stable state. But what does the interior of that state actually contain? The equations produce a singularity. The singularity is where the model breaks. General relativity describes GW150914 with precision. The chirp waveform, the infrared masses, the estimated distance of 1.3 billion light-years. Each of these falls cleanly out of Einstein's field equations applied to a binary merger. The theory handles the exterior of black holes with no visible seams. The interior is a different matter. At the center of a black hole, the density formally becomes infinite and the curvature of space-time becomes infinite with it. Einstein's equations return a singularity, a point at which the mathematical output loses physical meaning. This is not a small gap in the model, it is the place where the model terminates. No extension of general relativity currently resolves it without introducing physics that has not yet been confirmed by observation. Quantum gravity frameworks exist. None has produced a prediction that any detector has tested. GW150914 confirmed that the exterior description is correct. It said nothing about what lies inside because no signal from inside a black hole's event horizon can reach a detector. The horizon is the definition of the limit. The 7-millisecond delay between Livingston and Hanford placed the source in the southern sky, in a broad patch roughly consistent with the constellation Eridanus, though the two-detector network at that time could not produce a precise sky map. The localization region covered hundreds of square degrees. Electromagnetic telescopes searched for a counterpart signal. None was found, which was expected. Black hole mergers are not predicted to produce light. The gravitational wave was the only message. It arrived, it was measured, it matched the model, and then it was gone. The detectors returned to their ordinary hum of thermal and seismic noise. The collaboration spent months checking the result before going public. The announcement on the 11th of February 2016 was not a surprise to the team. It was a confirmation of something that they had been quietly certain about since September. Loop hash 1 payoff, partially. The moment the two black holes became one is captured in the ring-down phase of the waveform. The ring-down confirmed the merger. What it cannot confirm is the internal geometry of what formed. Whether the singularity at the center is a genuine feature of physical space-time or an artifact of a theory applied beyond its domain. The waveform ends at the event horizon. Everything inside that boundary is still no explanation. GW150914 was followed by additional detections as LIGO continued observing runs, and as the Virgo detector in Italy joined the network, the catalogue grew. Each new event provided another test of general relativity in the strong field regime. Each passed. The accumulation of detections has moved gravitational wave astronomy from a proof of concept to a routine observational channel. But routine does not mean complete. The question of what actually happens at the singularity has not become more answerable with each additional chirp. It has, if anything, become sharper. Every confirmed merger adds another data point showing that the exterior description holds. Every confirmed merger adds another object whose interior is beyond reach. The current LIGO-Virgo-Cagra network detects events at a rate that was not anticipated in the early planning documents. The sensitivity improvements since 2015 have extended the detectable volume considerably. Future planned facilities, including the Einstein telescope and the space-based LISA mission, will push the detection horizon further and access lower-frequency gravitational waves from different classes of merging objects. None of these instruments will resolve the singularity question. They cannot by construction. The singularity is behind the event horizon. The event horizon is, by definition, the surface from which no signal returns. Loop hash 2 payoff. The ring-down waveform from GW150914 told the team that the merger product behaved as general relativity, predicts for a black hole settling into a Kerr state, a rotating black hole described by its mass and angular momentum alone. The exterior settled. The interior is still no model fits. The two black holes that produced GW150914 had been approaching each other for an estimated 1.3 billion years. Their merger lasted fractions of a second. The gravitational waves crossed the field at the speed of light. They passed through galaxies, through the intergalactic medium, through the outer structure of the Milky Way, and arrived at two tunnels in Louisiana and Washington state where a laser beam happened to be waiting. The match between prediction and observation was so close that the team's confidence in general relativity's exterior geometry became, if such a thing is possible, higher than it had been before. The theory had passed a test in a regime no laboratory on Earth could reproduce. What remains open is what GW150914 cannot carry. The event horizon of the merged object is a one-way surface. Information about the interior, the state of the singularity, whether quantum effects smooth it or whether something else entirely replaces the classical picture, cannot propagate outward. No gravitational wave, no photon, no particle emerges from behind it. The detection on the 14th of September 2015 is, in this sense, a measurement taken at the edge of what measurement can reach, the waveform ends. The silence after that point is not a gap in the data, it is the physics. We know the chirp, we know the masses, we know the distance. 1.3 billion light-years. We know the ring-down matched the prediction. What we don't know, what GW150914 cannot tell us, what no gravitational wave detector currently proposed can tell us, is whether the singularity at the center of the merger product is a physical reality or the signature of a theory running past its own edge. That question was open before the 14th of September 2015. It's still open now, and no clean answer is in view. The signal from GW150914 matched every prediction up to the event horizon. Which part of the record stays with you, the chirp, the silence, or the edge the equations can't cross?
This was Voyager Notes. The signal is still coming back.